A question on probability distribution. Rachel and Sophia are competing in a javelin throw competition. The distances r meters, which is thrown by Rachel, can be modeled by normal distribution with mean 56.5 and standard deviation 3. The distances s meters thrown by Sophia can be modeled by normal distribution with mean 57.5 and standard deviation 1.8. In the first round of competition, each of them have been allowed 5 throws, and to qualify for, at least one of the throw must be more than 60 meters. So we have to find the probability that one of the Rachel or Sophia qualifies for the next round of competition. So let us start by finding the probability. Let's first for Rachel, that Rachel qualifies for the next round. Since her distances can be modeled by a normal distribution with mean equals to 56.5 and standard deviation equals to 3, we can use the standard normal distribution to calculate the probability of her throwing at least 60 meters. So for that we will calculate the value of z, that would be 60 minus 56.5 divided by 3, which will be 1.17. So corresponding to this 1.17, using a normal distribution table, we can find that the probability of a standard normal variable being greater than 1.17 is approximately 0.1216. Now similarly, we can go for finding the probability that Sophia throws a greater than 60. Now similarly, the probability for Sophia would be, the mean is given to us as 57.5, sigma is given as 1.8, so the value of z can be identified as 60 minus 57.5 divided by 1.8. So this comes approximately 1.39, and we know the probability for the value of z at 1.39 using a standard normal distribution, the probability will be approximately 0.0824. So these are the two probabilities that Rachel or Sonia throws a javelin for more than 60 meters. Now we need to understand that we need to find the probability that only one of Rachel or Sonia qualifies for the next round. Now for which, first we will try to identify the probability that in 5 throws Rachel throws at least one for more than 60 meters. So we will be using a binomial probability distribution that Rachel throws greater than 60 meters in at least one throw. So we will be taking several cases. For example, she throws at least 3 throws exactly in one, so 5c1. Probability of her throwing for more than 60 meters is 1.1216, and in rest of the 4 she has failed to throw, so this plus, now we are assuming she throws at least 60 meters in 2 times, so her probability for that outcome is this, then 1 minus 0.1216, that in rest of the 3 she doesn't throws for 60 meter. Similarly 5c3 0.1216, 3, 1 minus 0.1216, 2. Similarly 5c4 0.1216, 4, 1 minus 0.1216, 1, and then 5c5 0.1216 raised to the power 5. You can simplify this expression. On solving, you will get 0.4772. So this is the probability that in at least one throw out of 5 throws, Rachel throws a javelin for more than 60 meters, and the probability that Rachel does not throw any throw for more than 60 meters is 1 minus 0.4772, which will approximately be 0.5227. Similarly, for Sophia, throws for more than 60 meters in at least one throw, we can identify this using similar expression 5C1 0.0824 into 1 minus 0.0824 raised to the power 4, and so on. We will take again 5 cases up to 5C5 0.0824 raised to the power 5. On simplifying this expression, you will get the probability as 0.3495, and the probability of S not throwing any javelin for more than 60 meters in 5 trials will be 1 minus 0.3495, or approximately 0.6504. Now, the probability for qualifying at one of them is, suppose the probability that Rachel qualifies but Sophia doesn't, or the probability that Sophia qualifies but Rachel does not. So let us try to find this. So probability that Rachel qualifies is 0.4772, and the probability that Sophia doesn't qualify is 0.6504. Adding to this, the probability that Sophia qualifies is 0.3495, and the probability that Rachel does not qualify is 0.5227. So the outcome will be, you can simplify this expression using the calculator, you will get 0.4931, or approximately 0.493. So this is your solution, and for more such questions and their detailed explanation, do visit our website iitnacademy.com and register for regular updates. Thank you.